So you can, yeah, you can always refer back to this recorded video if you have questions. Okay, so in fact, you should be looking at the Sec 1 syllabus, okay, over here. So I think you can see the first chapter is on numbers and algebra. Okay, and then the topics that your school did not cover, or the topics that PSLE did not cover, will be here. And for rate and speed. Okay, so in fact, I will go through these topics with you in more details later on. Okay, because I find that instead of going through the P6 topics, which is much easier compared to this Sec 1 topics, so I will just do it later on at one shot instead of going through the P6 materials and then the Sec 1 materials separately. All right, so I will go through this topic with you when we progress. Okay, and for rate and speed. So today we will be looking at this. Okay, and you already have some you already have a taste of what this 1.1, 1.2, I think 1.3, what they are about. So I'm going to launch your homework. Is it here? Okay, not here. So let me send it to my MacBook. Are you using an iPad or what?
iPad.
Nice. Your camera looks so much clearer. Do you need to use a, okay, is it your old iPad or a new iPad?
New one.
Nice. Do you get yourself an Apple Pencil?
Yes.
Wow. Then from today onwards, please do the PDF using your Apple Pencil. Okay. In fact,
Okay.
these days we should not be using papers so much, and it's much easier for me to mark, and you save your mom from scanning your work as well. Okay. So we want to make life easier for everybody. Nice. Good to hear that you're using an iPad right now and with Apple Pencil. All right. So let's take a look at the topic 1.1, primes and prime factorization. So what are some examples of prime numbers? So did you learn this by yourself, or somehow you have already learned this, or you check it out somehow last night?
Already learned a bit.
Okay. Where did you learn this? Where did you learn this concept?
A book I bought from bookstore.
Okay. Very good. So in fact, this over here, these are some examples of prime numbers. So basically, we need to know what is the definition. Okay, that's the number one thing. What's the definition of prime numbers? Any idea? How do you decide?
A number that can only be divided by 1 and itself.
Exactly. So that is the official definition of prime numbers. So is divisible by 1 and itself. Okay. So in fact, I would like to add on one more. Okay. So there must be 2 factors. And I'm going to explain what do I mean by there must be 2 factors. Okay. So if you look at the number 1, okay. So the number 1, you can actually split 1 into 1 times 1, right? So 1 times 1, these are the factors. This is the first factor. Okay. And this is another factor. Okay. And these 2 factors, right? They multiply together and you will get 1. All right. Okay. So it's okay. So, okay. So you have just added a 2, but anyway, it's okay. So if you look at this, right? If you look at this and you realize that the first factor is 1 and the second factor here is also 1. And then it turns out for 1, you only have 1 factor. You only have 1 factor. So therefore, if you have only 1 factor, it violates this there must be 2 factors requirement. Okay, so if you just make use of the first requirement is divisible by 1 and itself, in fact, 1, the number 1 here, it meets this first requirement, divisible by 1 and itself. Okay, but it fails to meet the second requirement. There must be 2 factors. So that's the reason why I want to add on the second requirement. There must be 2 factors. Okay, and then it must be divisible by 1 and itself. Okay, so I will say these 2 requirements form the definition of prime numbers. Okay, so if you look at this definition, and with this definition in mind, right, the lowest prime number is actually 2. Okay, and then of course the first few prime numbers is 2, 3, and then 5, and then 7, and then of course 9 is not a prime number, because 9 you still can split to 3 times 2, 3 times 3. So 9 is not a prime number. So you will jump to 11, and of course 13, and then so on and so forth. Okay, so it's pretty easy, okay, to give some examples of prime numbers. So you just have to remember these 2 requirements. Divisible by 1 in itself, then there must be 2 factors. All right. Okay. By the way, in fact, later on I will talk about what are factors, and then later you will learn what are multiples. Okay. So first question done. Okay. So yeah, you have to add in 2. 2 is the lowest prime number. All right. Next, how to find the prime factorization of a number or several number? Okay, good. So over here it says divide the number using prime numbers, and afterwards times all the prime numbers. Yep. So I think you kind of have have an idea what this question is all about. Okay. In fact, prime factorization, basically it means you just have to find the prime factors, and then you just times all these prime factors, you times all these prime factors together to form that number or numbers. All right, so I'm going to give you an example. So if you have 22, okay, so if you have 22, okay, I think there are 2 ways to split 22. So let's talk about, this is the most conventional way. So of course you need to put a prime number. So the lowest prime number you can test is 2. Okay, so if you put 2, and clearly you have 11. I mean, you have 11 over here because you times. Okay, over here is times. Huh? So you will realize that 11 is a prime number over here. So that's why you stop. So whenever you reach a prime number, you stop. Okay. By the way, 1 is not a prime number. Okay, we just talked about it over here. 1 is not a prime number because it fails the second requirement. Okay, there must be 2 factors. So 1 is not a prime number. So 11 is a prime number. So therefore I stop. So the prime factorization of 22 is actually 2 times 11. All right, so that's how you can get the prime factorization. So basically you just times the prime factors that can give you 22. All right, so in fact, let's go on to have another example. So in fact, let's say you have 24. Okay, for 24, I'm going to show you the second method you can get the prime factorization. This is method 1. So method 2 for 24 is, you can do it this way. The first one is, the lowest is 2. You can test 2 first. So 2, and then you times 12. And then you know that 2 is a prime number which you cannot split anymore because it's already a prime number. So you split this 12. So for 12, you can split to 3 because 3 is the second lowest prime number. Or if not, you can actually test 2 again. Okay, you can test 2 again. So if you have 2, and then of course you have 6 here. So you continue, then you have 2 times 3. Okay, good. So both 2 and 3 are prime numbers. So that's where you stop. Okay, that's where you stop. You stop until you get a prime number. All right. So in fact, you just have to so-called pick all these numbers and then you times them together. Okay, so this is the second method. You can call this the branch method, in prime factorization. And of course, you can also use method 1. So far, so good? Okay,
Yes.
good, nice. And in fact, right, you can see that 2 times 2 times 2 times 3, right? In fact, you can do it, I mean, you can make it neater or tidier by having 2 to the power of 3, okay, to represent 2 times 2 times 2. So in fact, you have 2 cubed, and then after that times 3. So in fact, you can actually express your answer this way. Okay. By the way, this way of representing your answer is called use index notation. Okay. So don't be surprised. Next time you see, please represent your answer in index notation. What they mean is you just have to simplify it in this manner. Okay. So these are the 2 ways to find the prime factorization of a number. All right. So if you are asked to find the prime factorization of several numbers, so I have just demonstrated to you. So these are the prime factorization of 22. So these are the prime factorization of 24. So you just have to do it. I mean, you just have to do prime factorization for each number. So that will be prime factorization of several numbers. All right. So you have got this correct as well. Okay. So now, why do we need to learn prime factorization? So to make the solving easier. Okay, I'm not too sure whether you understand this question. Based on your answer here, I don't think you have answered the question. Yeah. So okay, later on, I'm going to let you see how prime factorization can be used to solve some real life examples. But basically, what prime factorization gives you is you are splitting a more complex number. So I consider this 24 as a complex number. So you split a complex number into the prime factors, so that you will see that, oh, actually 24 is made up of prime numbers, and it's actually made up of simpler numbers. All right, it's just like you have you have an onion, right? And then you just peel off the layers, and then you start to realize it's actually made up of layers. Okay, so and simpler numbers. Okay, and then later on I will show you how you can actually use prime factorization to solve real life example. So in fact, why do we need to learn is to solve real life examples later on. You will see later on. I'm going to give you examples. All right. Okay, so the 1.1 topic 1.1 is already covered, prime and prime factorization. Okay, pretty simple. Over here, give some examples of HCF and LCM. Do you have any idea what is these two? The definition of HCF is
common.
Yeah, and the definition for LCM is here. Do you have any idea what these two are about?
Like HCF is the same.
Common means same.
Common multiple.
Yeah. So say a common means same. So that's why when it comes to HCF and LCM, right? So first thing first, we focus on the word factor first. What's the meaning of factor? Okay, so I give you an example. If you have 4, so if I ask you to list down the factors of 4, so the common way to do is 1 times 4, and you can also have 2 times 2, right? So the factors of 4 is 1, 2, and 4, right? Okay, so can you see that the factors of 4, so if I am going to write factors of 4, and I hope you see that for factors of 4, right, you will see that all the factors here, they are You are still there, right? Okay, so if you are asked for the factors of 4, I hope you see that all of them, they must be less or equal to 4. The factors of 4 can never be more than 4. Okay, so please take note of this condition. So this is the condition. Okay, the condition is for factors of 4, right? They have to be smaller or equal to 4. You can see, right? It can be equal to 4, but it has to be smaller than 4. Okay, if you talk about factors of 4. Okay, so that's the meaning of factors. Okay, and now let's talk about what's the meaning of multiple. This word multiple. Okay, so multiple of 4, right? For multiples of 4, right? In fact, not only one, multiples of 4, more than one. So for multiples of 4, right, you realize that 4 times 1 is the first multiple of 4. 4 times 2 is the second multiple of 4. 4 times 3 is the third multiple of 4. In fact, it goes on and on, but we are not going to write down all of them. So you will see that the multiples of 4, the condition is more or equal to 4. Okay, so the condition for multiples, right, is it has to be bigger. That's why I use a bigger sign, or equal to 4. Can you see? It can be equal to 4, and then it has to be more than 4. Okay, so this differentiate. Okay, this differentiate the factors and then multiples. So for factors, smaller or equal to 4. That's the condition. For multiples of 4, it has to be bigger or equal to 4. So this is the condition. Okay, I'm going to tell you why you need to know the meaning of these two. If not, you are going to get confused. Okay, so you have listed down 20 and 16. Okay, so let's make use of these two. So for 20 and 16, right? Before you learn the prime factorization just now. So over here, we have learned how to do prime factorization, right? So let's make use of prime factorization now, okay? To find the prime factorization of 20, and then to find the prime factorization of 16. And I'm going to use PowerPoint to show it to you. Oh, by the way, talking about PowerPoint, right? Yesterday, I'm not sure. Saturday, yeah, on Saturday, then Yusing showed me her latest PowerPoint about one of her science projects. Okay, so I'm not sure if you need to do the same project. Do you need to do the same project?
I don't know which
one. Okay, never mind. So basically, she asked me how she can actually improve her PowerPoint. Okay, so she's doing her science project. So I just sent her this. This is just an example, the first slide. So I just want to share with you as well. So in fact, if this is my presentation on music, so in fact, you can actually create a PowerPoint slide like this. You can add in this kind of artwork, and then you can add in logos, and then of course you can also add in a video. Can you hear it?
Yes.
Okay, good. So I'm just trying to show you there are a lot of things you can add to your slide instead of words. Okay, so next time when you create a PowerPoint, and if you want to create a good PowerPoint for your teacher or your for your classmates, so you want to share info with them, you could have done something like this. But this is not the gold standard, but this is something for you to build on, okay, to give you some idea. All right, so hopefully you also can learn something from this slide, and next time you can have a more interesting PowerPoint slides. All right. Okay, so go back to our this topic. So 20 and 16, we are going to do prime factorization first. So I'm going to open new. All right, good. So over here. So Okay, so you have chosen 20 and you have chosen 20 and 16. Let me insert. Okay, 20 and then 16. Okay, the first thing I need to do is I'm going to do prime factorization first. So the lowest is 2, so I will get 10. The lowest is 2, I will get 5. 5 is a prime number, I stop. So 20, if you prime factorization 20, you will get 2 times 2 times 5. Okay, from today onwards, I'm going to use index notation, okay? So it's 2 squared times 5. Over here, divide by 2, you get 8. Divide by 2, you get 4. Divide by 2, you get 2. 2 is the prime number, I stop. So 16 is, how many 2 you have? 1, 2, 3, 4. Okay, so it's 4 to the power of 4. 2 to the power of 4. So this is how you read it. 2 to the power of 4. That's how you read this 2 to the power 4. All right. So with this, you see that this is the prime factorization for 20. And then this is the prime factorization for 16. But now we are interested in HCF and LCM. Okay. So just now we talked about, so let's talk about HCF first. Okay, let's talk about HCF. So I'm going to erase over here. I'm going to erase this. How do you find the HCF? So for HCF, what we learned just now is, because it's about factor. So factor is, what was the meaning of factor? Factor, it means it must be smaller or equal, right? Remember the condition? Smaller or equal. Okay, so just to refresh your memory a bit, can you see? Factors of 4. So must be smaller or equal to 4. So the condition is smaller or equal. So similarly, if you come back to the presentation, so for the HCF, we're talking about factors. So it must be smaller or equal. So if we talk about HCF of 20 and 16, right? So you can actually think of it as between 20 and 16. 20 is bigger than 16, right? So this condition must be smaller or equal, right? So it has to meet 16. So that means the factor definitely is smaller than 16. Okay, it is definitely smaller than 16. It cannot be smaller than 20 because 20 is bigger than 16. Okay, so you take the lower number and then you need to find a factor that is smaller and equal to 16. Okay, so between the 20 and 16, right? So how do you pick? How do you pick? So if you have not learned prime factorization, if you have not learned, I guess what you learned last time is this. So basically you just do this, list them down first, right? And I'm going to show you, okay, 5 times 4. No, in fact, you don't need 5 times 4 because it's a repeat. So you just list them down. So the factors, I'm going to show you your P6 method. Factors of 20 is 1, 2, 4, 5, 10, and 20. And you are going to do the same for 16. So 1 times 16. And you are going to see that it's pretty tedious. Okay. Okay, good. That's it. Then factors of 16 is 1, 2, 4. You're not going to write 4 again. You just have to write 4 once. Can you see? So you just write 4 once. 8 and 16. So among all these factors, then you pick the highest, right? Highest. So you will see that they both have 1, they both have 2, they both have 4, and then yeah, that's all. And then you pick the highest. So in this case, 4 is the highest. So in fact, if you want to find the HCF of 20 and 16, right, using your P6 method, the answer is 4. Okay, you can use this method, okay, when the numbers are small. Okay, imagine you are going to do 2000 and then you have 4800. Imagine you are doing numbers of this scale. You are not going to use this P6 method anymore because it's going to take a lot of time and you don't have so much time in your exam. Oh, by the way, you said you did not finish your PSLE. What's the reason? I'm just curious.
Didn't have time.
Okay, good. You see, so time management. Yeah, once again, let's come back to this key exam strategy. Time management is so important. So you have to use a better method or you have to use a faster method. Of course, the basis is you have to get it right. Okay, no point you figure it out fast, but you get the wrong answers. Okay, so if you are doing large numbers like this, you're not going to use this method anymore because it slows you down so much. It's like your iPad 1. Okay, so slow. All right, so I'm going to make use of the prime factorization method to show you can quickly get the HCF. So for 20, we already split to 2 to the power of 2 and 5. Right? And then for 16 is 2 to the power of 4. Okay, so given this 2 prime factorization, to find HCF, okay, number 1, so it must be shared factors. Number 2, pick the highest power. Okay, you just have to use these 2 ideas. Then you can find the HCF of 20 and 16. Okay, let's do it. It must be shared factors. So you can see that among these 2, right? 2 is shared, right? 5 is not shared, so I cannot choose 5. So I choose 2. And then what else? So I need to pick the highest power. Actually, I'm wrong. You're not supposed to pick the highest power. You're supposed to pick the lowest power. I'm going to explain to you why. Because you must be thinking, hey, over here is the highest. How come I choose the lowest power? Highest common factor, shouldn't it be highest power? This is also something very contradictory, very counterintuitive. It's like, it doesn't make sense, right? So why choose the lowest power? So the lowest power is actually 2 and 4, I choose 2. So actually the answer is 2 to the power 4 is 2 to the power 2 is 4. Do you know why lowest power? Do you know why?
No.
Because the HCF, the definition of HCF is highest common factor. Over here, the word is highest. But how come when it comes to this second idea, right? How come I choose the lowest power? Okay, let's choose the highest power instead. Okay, so the shared, okay, let's follow. Number 1, shared factor. The shared factor is 2, right? Okay, let's follow highest power. The highest power between 2 and 4, the highest power is 4. So 2 to the power 4 is 16. So then you ask yourself, 16 is inside 16. Okay, there's nothing wrong with that. But the question is 16 inside 20 or not? Is 16 inside 20? And you realize no. 16 is not a factor of 20. Right? 16 is not a factor of 20. Right? So in a sense, if you take 16, right? If you take 16, right? Yes, you can meet this requirement if you pick the highest power, but you violate the first requirement. It's not shared. 16 is not inside 20. as a factor, right? That's the reason why, in fact, you will know whether you make the right decision or not. Okay, so imagine during the exam, okay, during the exam, somehow you forget, hey, I remember is shared factors, but I cannot remember whether I picked the lowest power or highest power. So you end up with this answer. So let's say you end up with 2 to the power 4 equals 16. Okay, what you need to do, you just ask yourself, is 16 inside 20 or not? So you realize, no, 16 is not a factor of 20. So you realize, oh, I shouldn't choose the highest power. I should choose the lowest power instead. So does it make sense to you now?
Then can I use like I put them together and prime factorization and divide though they cannot.
Very good. So basically what you are saying is you are doing it this way. So you have 20, you have 16, right? So you do the prime factorization. So the lowest is 2, right? So you get 10. So you get 8, right? Then after that, you do one more time, 2. So you have 5, you have 4. And then when you reach 5 and 4, right, you see that there is no common prime numbers anymore except 1. By the way, 1 is not a prime number, so you cannot continue, right? So from here, you just pick these 2, right? That's what you are talking about, right? Okay, good. So in fact, this is also one way. Okay, this is also one way for you to find the HCF. Okay, I am showing you this way. I'm showing you this way. Okay, find your HCF from its prime factorization, right? In fact, I'm also looking at how you find LCM. Okay, how you find LCM. So if you do it this way, you can find the HCF. Yes, no doubt about it. But you still have to do for the LCM. So I am going to show you how you can do the LCM using the prime factorization. So let me write down 20 is 2 to the power of 2 times 5. 16 is 2 to the power of 4. Okay, just now we talked about the multiples, right? The multiples of something, let's call it x, has to be bigger or equal to x. So now you know that this LCM of 20 and 16, right? It has to be bigger or equal to 20. Okay, it can never be smaller than 20. Because if you choose 16 here, right, you realize that you never meet the 20 requirement. So that's why you need to choose the bigger number. Okay, so it has to be bigger than 20. Then you will not get like sometimes students they so-called they make a mistake. They just confuse yourself. Okay, they choose 4. So the LCM of above here is 4 because they just make a mistake. Okay, but if you remember the multiple of x, right, has to be bigger than x, right? Then you will realize that, oh, the multiple of 20 and 16 must be bigger than 20. So once you write down this requirement, it must be bigger than 20, then you realize that you will not confuse LCM with HCF. This is a common mistake among students. Okay, this is a very common mistake among students. Okay, Ken? So LCM, let's talk about LCM. So for the LCM, I also have 2 ideas for you. So for LCM, idea 1 is write down all prime numbers. Idea 2, pick the highest power. Okay, so these are the 2 ideas for you to pick the LCM of 20 and 16. So write down all the prime numbers. So I see what? I see 2. No need to be shared. As long as they are there, just write them down. So you have 2, So you have 2 2s, you just write once. Okay, so 2 is there. And I also see 5. So I just write down 5. And then the second idea is pick the highest power. So the highest power for 2 is 4. Okay, so I just pick 4. And then for 5, the highest power is 1. So just put 1. So you will see that is 2 to the power 4 times 5, 16 times 5 is 80, right? So 80 is the LCM. Okay. So now, once again, you must be asking, hey, over here is the lowest common multiple. How come over here you pick the highest power? Okay, let's choose the lowest power. So I have 2 as the prime numbers. I have 5 as the prime numbers. So between 2 and 4, I choose the lower power, right? So it will be 2. And then you will end up with 20. And then you will see that 20 is a multiple of 20. But 20 is not a multiple of 16. Right? Then you have answered yourself. You cannot choose the lowest power. Does it make sense to you now?
Yes.
Yeah. So what I'm trying to show you here is, I know that if they ask for lowest common multiple, and then the second idea here is pick the highest power, I know somehow it's like so against our common sense. Okay, it's so against like a common sense. But if you put the lowest power and you realize this doesn't make sense, I mean this answer doesn't make sense. So I call these countermeasures. So what are countermeasures? Just like you have 2 times 3 equals to, let's say you put 16. Let's say you put 16. You make a mistake. So how do you know that you make a mistake? So what you do, you just write 16 divided by 3. Then you see whether you get 2 or not. And you realize you don't get 2. It's not equal to 2. And then this, I will say, this is a countermeasure. Countermeasure means it help you say, I mean, it help you spot your mistake before you submit your work and then marked it by your teacher. Okay, so before you submit your answer 16, you know that, oh, 16 is not the answer because 16 divided by 3 cannot be equal to 2. So I want to show you some countermeasures. So if you somehow make a mistake and you follow the mistake, you realize that 20 is not a multiple of 16. So 20 is not the answer. So if 20 is not the answer, you know that lowest power doesn't work. So you need to put the highest power instead. So far, so good. So far, so good. All right. Can or not?
Can.
Good. So in fact, right, normally, if you use this method, which proposed by you, I think is very, very, I mean, I find this method valid. Okay, I find this method valid. Okay, but it's only valid for HCF. Okay, it's only valid for HCF. How are you going to do for LCM? Okay, you might not be able to do for LCM. So instead of teaching you just one method which can only help you solve HCF, right? I would like to teach you a method that you can actually find both. Okay, HCF and LCM. Okay, which is this. Remember that these 2 ideas. Shared factors, pick the lowest power for HCF. And then of course, when it comes to this, write down all the prime numbers and then pick the highest power for the prime numbers for the LCM. Okay, so in fact, you just have to remember this, okay, 2 ideas for each of them, then you shouldn't make any mistake. Even you make a mistake, you will somehow realize that you make a mistake. All right, so there are countermeasures to put you back on track if you go off track. So far, so good?
Yes.
So in fact, I've been talking about prime factorization and the HCF and LCM, right? I have not talked about how these ideas can be used in real life, right? I have not talked about that. So we are going to talk about that now. So this question, done. How to find the HCF and LCM? Okay, done. Why do we need to learn? Yeah. So it helps to solve question about speed. I'm not too sure if we can solve the speed question, but definitely we can solve some questions later on. I'm going to show you now. Any more question I give you? Okay, here later on. I'm going to show you an example. Let's go to the shared folders. By the way, I'm going to share with you this link. Let me just send you this link. Then you just have to go to this link and then you can look for your homework. So in fact, you have done your homework 0. Can you see it over here?
Yes.
All right. So in fact, over here, how you can read is 2021, which is the year. S1 is set 1. Homework 0 is, yeah, homework 0. So homework 1 is your next assignment. All right. And then of course, homework 1A is extra homework. Okay. So of course, this is homework 2 and then homework 3. All right. So that's how you can read. Okay. And then, yeah, so I will upload the homework by the next day. Okay. So just give me a few days. Like, okay, generally it takes me 3 days. Okay. I will definitely upload. If I have not uploaded the latest, then please let me know. All right. Just let me know. But usually I will upload. Usually I will upload homework right after the next day. All right. Okay, so let me give you some real life examples. Okay, so one of the real life example is this over here. Can you see this question? It says,
yes,
Priyanka has 2 pieces of cloth. I think you also encountered this question during your P6 career. But somehow you don't know actually you can make use of HCF or LCM to finish to solve it. Okay, so Priyanka has 2 pieces of cloth. So basically, one piece is 22 inches, and then the other one is 90. So she wants to cut both pieces into strips of equal width that are as wide as possible. How wide should she cut the strips? So basically, right, you want to cut 72 into number of strips. Okay, and then you also want to cut 90 into number of strips. Okay, but the requirement here is these two must be of the same length. Okay, so not only must be of the same length, it must be as wide as possible. Meaning, right, for 72 and 90, right? Okay, so for 72 and 90, if you don't choose the as wide as possible, then you might as well just cut into 1 each. Then you will have what? 72 of 1 each. Then you have what? 90 of 1 each, right? So, but no, we don't want the smallest. We want the largest. So what is the largest width that you can cut? Okay, out of 72, out of 90, so that these two, they are of the same length and largest. Okay, so how you do it if you are a P6 student? Any idea?
List out all the factors.
Good. So in fact, you can list down all the factors, but 72 looks like 72 is quite a big number, right? So I'm thinking it's going to be quite tedious, right? Okay, if you continue, right? So probably you will spend more than the time required for this question. Okay, especially if you do numbers of 3 digits. We are talking about number of 2 digits, and you have already spent a lot of time. So in fact, for this question, what you could have done is you can actually just make use of the prime factorization method or the one you use. Okay, so let's do it on the PowerPoint slide. So you have 72. So how do you do the prime factorization? Like you say, I can do it this way. So you have 36, and then you have 2, then you have 18, you have 2, you have 9, then 3. Okay, good. 3 is a prime number. I will stop. How many 2 you have? 3, 2. How many 3 you have? 2, 3. So the next one is 90. So I do the prime factorization. So I put 5. Oh, by the way, you must put prime numbers. Okay, I'm talking about prime factorization. So you must put prime numbers. You cannot put 9. You cannot put 9 here. You put 9 here, 9 is not a prime number, so you cannot. Okay, so just continue. 5. So you get 9, and then 3 and 3. All right, and then you realize, so 90 can be split into 1, 2, then 2 3s, and then of course 1 5. Okay, so in fact, this and this. Okay, so now you must be asking yourself, should I give HCF or LCM for the answer to the question just now? Let's do for both. For HCF, I remember is must be shared, and then choose the lowest power. So what is shared here? 2 is shared. 3 is shared. 5 is not shared. I cannot pick. So I just pick 2 and 3 first. And then for the lowest power, 3 and 1, I choose 1. 2 and 2. 2 and 2 is equal. So I just pick 2. So 2 times 3 times 3. So basically you get 18. So this is a HCF of 72 and 90. So let's do for LCM. So for LCM is all prime numbers, all primes, and then highest. Because since I choose lowest power here, so I must choose highest power here. So all prime. So I see 2, I see 3, I see 2, I see 3. I just write once, I see 5. What's the highest power for 2? Between 3 and 1, I choose 3. Between 2 and 2, I choose 2. 5, 1. So the highest power and then all prime. So you end up with 8 times 9 times 5. So I can do this one first. So it's 40 times 9. So it's 360. Okay, good. So with this, can I ask whether you should use HCF or use LCM for this answer, for this question?
HCF.
Yes. Okay, so basically the highest common factor, which is 18, right? Okay, so 18 cm. Okay, you can actually verify yourself. So if you cut 18 cm out of 72, you are going to have 4 pieces, right? So if you cut 18 cm for each out of 90, you're going to have 5 pieces, right? Okay, so 18 is the widest possible strip, okay, for each strip you can cut. Okay, so these are a real life example how you can actually apply HCF. Okay, so it's much easier than your P6 method. Okay, for P6 method. Okay, for P6 level, the numbers won't be this large. Okay, for P6, I think probably you are only given like less than 50. Okay, probably you get 24 and 48. So which is easier because they know that you're not going to use HCF or LCM. Okay, so this real life example demonstrate to you how you can actually make use of HCF, okay, to find answers for this example. Okay. Okay, let's move on. Now, so LCM. So for this, you can see that, okay, hold on. You can see that RAM exercise every 12 days, and then typical every 8 days. So RAM and typical both exercise today. So how many days will it be until they exercise together again? Okay, until they are exercise together again. So once again, in fact, a lot of students, they are confused. Okay, should I use HCF or LCM? In fact, you just find out both, and then you see which one makes sense, and then you just pick that one. Then you don't get confused. Okay, so let's do HCF and LCM together, so that then we will see which one fits this question. All right, let me just get this question out. Put it on this. Oh, it disappears. So I have to pick it from this. Is it this? Okay, good. This is the one. I hope you can see my screen. Okay, so you have 12. You have 12. And then you have 8. So before I do anything, I do the prime factorization first. So in fact, you can quickly do it. If you're fast enough, you can even verify whether you are correct or not. So it's 2 to the power 3. Okay, so I'm going to do HCF and LCM. So for HCF, I remember must be shared lowest. Then this all prime highest power. Okay, I write it down in case I forget. So for HCF shared, I see 2 is shared. So I pick 2. So lowest power between 2 and 3, I pick 2. So HCF is 4. LCM, all prime numbers. So I see 2, I see 3. So I write it down first. And then highest power. So highest power between 2 and 3, I choose 3. And then 3, you only have 1 power, so you choose 1. And then after that, you will get, this is 8. 8 times 3 is 24. Okay, so between 4 and 24, you can see if RAM exercises today, and then typical exercise today. Okay, so let's say this is today. You'll realize that after 24 days later, right, they will exercise together again. Okay, if you consider today is the first day, so it will be 25th. Okay, if you consider, it really depends. If you consider today is the 0 day, right, you don't count today, right? Let's say you don't count today, then it will be 24. Okay, so depends how you look at this. Okay, so there is no fixed answer, because sometimes people, they take today as the 0 day. Okay, so sometimes people take today as the first day. Okay, but anyway, 24 is the answer. So how many days later? So 24 days later lah. So far so good.
Yes.
So in fact, right, what you need to do, you just find out HCF and LCM. It shouldn't take you a lot of time, but anyway, you will know that which answer is actually applicable for this question. So in fact, for this question, you should pick the LCM 24. All right. So that's how you can actually make use of HCF and LCM to tackle real life examples. All right. Okay.
Okay.
So instead of just writing down the HCF and LCM of the 2 numbers, so in fact, please be noted that they can be used in our real life. Plus, in fact, regardless whether you use HCF or LCM, the number 1 step is prime factorization first. Once you have done the prime factorization, you just remember the 2 ideas for HCF and then the 2 ideas for LCM. Okay, so if you remember this, then you should be able to find HCF and LCM very quickly, even though you are dealing with large numbers like 72 and 90. If you remember the two tips I give you for each of HCF and LCM, you can actually find out the HCF and LCM very fast. Okay, so if you do it this way, like the one you propose is valid, but it has its limitation, I will say. It has its limitation. Can I ask you, where did you learn this from?
I thought about LCM because LCM is like divide until 1.
Okay, if you divide until 1, so how do you continue for this? Are you going to divide by 5 or 4 or something?
I will.
Please do it.
5 and then this stays. Then
divide by 4 again.
2 and then 2.
Okay.
I mean 1.
Okay, then how you continue to find the LCM?
And then the LCM is 2 times 5 plus, times 2. So 2.
You mean here? You mean here?
Yeah.
Okay, let's take a look. I have not. I probably have learned this method, but okay. I don't use it anymore. Yeah. So let's do it. Let's test what you propose. 20 and 60. Because I find that it might not work for bigger numbers, or I find that it's less convenient for bigger numbers. Okay, let's do it together. So it's 2, 10, and then you get 8. So you put a 2 again, you get 5 and 4. So you were saying put a 5 and you get 1 and you get 4 here, right?
Yes.
Okay, so now the question is, how can you put a 5 here? You will get 4. I thought you are supposed to get 0.8. Because I'm not sure, because over here you clearly, if you put 5 here, what you have done is you're actually doing for the 5 only. You're not doing for the 4. That's what you're saying. If you put a 4 here, if you put a 4 here. So I will say logically, this might be wrong. Logically. Okay. So I just want to let you know, logically, this can be wrong. Okay. Because it doesn't make sense. If you put a 5 here, so what you are actually doing is, okay, 5 divided by 5 is 1. Okay. This one works. 4 divided by 5, you're supposed to get 0.8. Okay. So logically, if you don't put 0.8, okay, you put 4, right? You have basically from here onwards, if I put a division line here, from here onwards, the method here you use and the method here you use, they are different. Okay, over here you divide both by 2. Over here you divide both by 2. But how come suddenly you go to this step, you only divide one of them? You understand my point? So that's why I say logically, this can be wrong. Okay, Ken? So just to let you know, it might work, but logically it is wrong. So I don't want you to use I just want to be safe so that you don't end up with we call it ambiguous. Ambiguous means not clear. It can be this, can be that, that kind of thing. Then suddenly you do this for this, then suddenly you do this for the rest. So this is called ambiguous, not clear. All right. So I don't recommend this. I don't recommend this way of doing things for LCM and HCF can be done, but LCM you might not want to do it. Okay. Okay. But very good to hear from you. because what I realize is when it comes to mathematics or other subjects, right, it's all about discussion. Okay, so don't be afraid of proposing another method. We are here to discuss. Okay, if we find it useful, we will adopt it. But if we find it not useful, then we have to reject it. We have to reject it. Okay, but it's very good to learn from you. You can actually do this for HCF. All right. Yeah. Okay. So before we continue, we take a brief break, shall we?
Okay.
Yeah, let's take a brief break and we'll come back in 5 minutes. Okay. Okay, see you. Yeah, hello, welcome back. Let me know when you're back. Yep, welcome back. So, can you hear me?
Yes.
Nice. Okay, so we were talking about how HCF and LCM can be used in our daily life. Okay, by the way, I'm not sharing, I'm just sharing a white canvas. So you should be seeing a white canvas. Am I right? Or something white. Good. So, okay. So why do we need to learn? Yes, so we need to learn HCF and LCM so that so we have looked at some daily examples, how we can use HCF and LCM to speed up our solutions. So I'm not too sure about speed, or you have any idea about how these two can be used in the speed question?
No.
No. Okay, good. So not yet. At least, okay. I'm not too sure, but I can't think of a question that involves HCF and LCM. Okay. Not yet. Not yet. If I have thought of one, I'm going to let you know. Okay. Next, over here, finding the highest. Okay, done. Lowest, done. Squares, cubes, cube roots, and square root and cube root. Okay, good. So it helps to differentiate whether a number is a square number or not. Then it helps to find the square root of a square number. Okay, I think you kind of understand what this question wants you to know, but I would like to elaborate further. So you have 2 to the power of 2, so this is called 2 squared. Okay, if you have 2 to the power of 3, this is called 2 cubed. Okay, so just like plus and minus, times and divide. Okay, so plus and minus, they are opposite to each other. Times and divide, they are opposite to each other. So when you have 2 squared, right, the opposite of squared is actually square root. Okay, if you don't know yet. So 2 squared, I mean squared means the opposite of squared is square root. We'll use short form, square root. So of course cube is cube root. Okay, so the symbol for square root is this. Okay, the symbol for cube root is this. Okay, so do you have your calculator with you?
Yes.
In fact, even if you don't have a calculator, let me launch my calculator. Can you see my calculator here?
Yes.
Good. So in fact, if you look at my calculator, right, the square root is here. Can you see it? Just look at my screen first. So cube root will be here. Okay, so in fact, you can see next to here is y and then square root x, right? Can you see this? Y and square root x, right? Can you see it?
Yes.
Okay, good. So in fact, we will focus on these three, and I will elaborate with PowerPoint slides because I have more space here. So let me put my calculator on top of this. Okay, good. Okay, good. So like I say, 2 to the power of 2, you get 4, right? Okay, so 2 square, you get 4. Okay, so the opposite of, so that means, how do you get back to 2? So you just square root 4, you get 2. So you can actually make use of your calculator. So I can do a demo here. So if I press 4, if I do a square root of 4, then you get 2. Okay, you can also test it out on your calculator. You want to test it out on your calculator? All right, you get 2, right? Good. So square and square root. Now cube and cube root. So 2 to the power of 3 is 8. Okay. Oh, by the way, 2 to the power of 3 is 2 times 2 times 2. If you split them. By the way, this is called index notation. Once again, just to highlight to you, this is called index notation. So next time when you see the word index notation, you shouldn't be alarmed. Okay. So basically, they want you to write in this manner. So if you have cube, then you just cube root. So when you cube root 8, so let me demonstrate to you. So I have 8, then I press cube root, then you get 2. Yeah. Very simple. Okay. So test it with your calculator. Okay. I hope you're done. Okay. So now you must be asking, then what is this about? I mean, this y square root x. I think you also have this symbol in your calculator, but probably you need to use the shift key, like the second function. Okay. Okay. Let me demo to you what is this about. So we have 2 to the power of 2, which is called 2 squared. 2 to the power of 3, 2 cubed. In fact, what about 2 to the power of 5? We talked about 2 to the power of 4 just now, right? So what about you have 2 to the power of 5? So if you have 2 to the power of 5, right, you should end up with 32. Okay, you can test it out. How do you key in 2 to the power of 5, by the way?
The something x.
Yeah, correct. So in fact, if you look at your calculator, you should have something like 2, and then there is a power there for you to key in any number you want. Can be 5, can be 12. Let me see if I have it here on my calculator. I have it here also. Have you tested 2 to the power of 5 is 32?
Yes.
Good. So in fact, if you look at my calculator here, the symbol is here, x to the power of y. Okay, so I key in 2 first. So x to the power of y. So they asked me to put in 5. So yeah, it's 32. Okay, so now, similarly, if you have 2 to the power of 5 is 32, right? In fact, you can actually do we call it this. So what you need to do to get back this 2 is you just do this. Okay, square root with a 5 outside. Okay, so if you square root with a 5 outside, you should get 2. So you can test it. I test it here. So I just put this and I put a 5 and I get 2. Yes. Okay. So I'm just showing you how you can get the answer for any power, and you will get back the same answer if you do the square root. Okay, with the same power. Okay, so like I say, square and square root is the opposite of each other. Oh, by the way, just to highlight to you, over here the square root sign, right? Without writing the 2 here, actually you can actually write a 2 there also. But generally, when it's 2, right? We don't write it down. But in fact, you can actually this is what it means. Square root. If they don't write the 2, that means it's supposed to be square root 2. Let's test it. All right, let's test it. Let me put a 4, and then I write here. Yeah, I write 2. Yeah, so it's supposed to be 2. If they don't write anything here. All right. So far so good.
Yes.
Good. So you must be wondering, when do we need to use this square and square root? You have any idea? In real life, when are we using this?
To find the square number.
Okay, so when the area of the square, right? So in fact, let's say this is 10, this is 10. So how do you find the area of this? It's 10 times 10, right? So if you write in index notation, is 10 square, right? So 10 square, you can use calculator, so you should get 100. All right, of course, with the unit is cm squared. All right, so if If they don't give you the length of the side, they just give you this. Okay, how do you find? And they tell you this is a square. How do you find this? So what you do, you just square root 1 to 1. So you get 11, right? Okay, so if the unit is 11 cm. So does it make sense to you now? When you need to, when you can actually use this. In fact, there are many examples you can make use of square and square root. Okay, example for cube root, probably you are already learning, like you are talking about the 3D object, right? So let's say this is a cube. How do you find the volume of a cube? Okay, let's say this is a cube, so it's side times side times side, right? In fact, it's side to the power of 3 or side cube, right? So if they give you one of the side is 4, so in fact you can 4 cube is 4 times 4 times 4 is 64 cm cube, right? So reverse, if they give you the cube, they don't give you the side, but they give you the volume, so it's 8 cm cube. So what you do to find the length of the side, you just cube root the 8, then you end up with 2 cm, so it's 2 cm each. Does it make sense?
Yes.
Then what about the 2 to the power of 4 and then all those? Can you think of any real life example? 2 to the power of 4, 2 to the power of 3 and all those?
I'm like I'm what is it?
If you can explain better with drawing, you can also do that. I can give you a canvas.
I'm a supplier.
Okay, you're a supplier. Okay, I give you a whiteboard. Okay, you can draw on the screen. Yeah, if you can, if you don't need, then you just voice out. Yeah, you're a supplier, and then
like I work for a restaurant, and I help to buy all the food.
Okay.
And then I need to buy tomato. And I have to buy. Okay, that doesn't make sense.
Okay. Okay. Interesting.
I'm building a.
Okay, you can clear this. Yeah, you can clear this. Yeah, you are building a building. Yeah, you are constructing a building.
Yeah, I'm constructing a building. And it's in the shape of a cube.
Okay. Yeah.
And I have to find the total area.
Total area. You mean the surface area or?
Volume.
Volume. Volume is side times side to the power of 3. Yeah.
Yeah. So one side is. One side is
10 meters.
Okay, 10 meters. So if I want to find the volume, 10.
Yeah, 10 cube. Yeah. Yeah, nice. Can you think of an object is a cube, like a building in the world, well known? Have you heard of the water cube in Beijing? For the
no.
Okay, so there is a water cube in Beijing. It's well known and is used for the swimming competition. Yeah, in the Beijing 2008 Olympics. Okay, so that is by the way, the place is called water cube. Okay. I'm not sure about the dimensions. Okay, in fact, this 10 meter and then all these, right, these are called the dimensions. I'm not sure about the dimension of the water cube, but I know that the Olympic swimming competition was held in the water cube in Beijing. Okay, this is a very good example. Then what about power more than 3? Like 4, 5, you know, all those. What about?
Just
you can clear this, yeah. Let me clear all this. Yeah. Okay, you can. Okay, never mind. So okay, so in fact, until PSLE, I think the numbers we deal with is, I think, maximum. Probably you are doing a 9 digits. Okay, you're probably doing a 9 digits number. That means the range is a 9 digits. You know why? Because I think your calculator can only accommodate 9 digits. In fact, you just key in pi. You want to see the value of pi, right? They only give you what, 3.14. Oh, I cannot remember already. But they only give you until the 9th digit. Can you help me out? 3.1415926. Oh, 26 what actually?
Uh, 3.141592654.
5. Okay, good. So we stop at here. 94. Okay, good. So it's 3.141. Okay, so it's 3.141592654. Then they stop.
Yeah.
Okay, good. So in fact, your calculator can accommodate how many? Oh, 10 digit. So your calculator is better. So I underestimate your calculator. But anyway, so your calculator. Are you having a new calculator?
No, still old.
Oh, old one. Okay, never mind. So, okay, in fact, your calculator can accommodate only 10 digits. In fact, you know that pi is actually indefinite. Pi is actually indefinite. Indefinite means it will go on, and then it will never stop. Okay. So your calculator, the capability of your calculator is only 10 digits. That's why until P6, or actually until P6, you only need to learn numbers of this range. Okay, the maximum range is 10 digits. But in fact, right, going forward, right, you are going to learn numbers more than 10 digits. So how are you going to do that? How are you going to accommodate number more than 10 digits? So I'm going to show you now. So actually now, when you move on to secondary school, in fact, the numbers range is going to explode. Okay, it can be any range. Okay, any range. Okay, what do you think? Have you ever wondered what is the number of cells in you or in a human body? What do you think? Millions? Billions? What do you think?
1 trillion.
Yeah, or more, right? Okay, good that you use the word trillion. Okay, so this is 10, this is thousands, so this is million. Then of course you have 1 billion, and then of course you have 1 trillion. Can I ask, for 1 million is 60, so it's, let me use a comma. For billion is 9 zeros. So for trillion is 12 zeros. I hope you know. Do you know about this? Do you know about this? 1 trillion is actually 12 zeros.
No.
Okay, never mind. So you know the word trillion without knowing the exact meaning of trillion. But after today, you should know. 1 million, 6 zeros. 1 billion is 9 zeros, and then 1 trillion is 12 zeros. And normally we should stop at 1 trillion, because I think beyond 1 trillion, the number is too big for us to comprehend, and there is no meaning anymore. Okay, it's just like if I tell you we have 1,0,0,0 cells in our body, you know, it doesn't make sense to you already. So we try to have numbers that make sense to us. Okay, so I don't know the number of cells in our body, but probably is more than 1 trillion. So let's fix it, 1 trillion. So how do you put 1 trillion in your calculator? Your calculator cannot accommodate more than 10 digits, right? Over here is how many digits? 13 digits. So your calculator is not going to accept 1 trillion, right? So how do you going to write down 1 trillion in your calculator? What if they ask you to add 1 trillion with 2,346? How are you going to key this into your calculator? You can't, right? Because you try 1 trillion to your calculator.
12 0.
Huh?
12 0.
Yeah, 12 0. 1 and then 12 zeros. Yeah. I also want to know whether your calculator can accept or not.
Can.
So what your calculator show you? I cannot see. I'm sorry. Can you just read it out to me?
1 where?
1 times 10 to the power of something, right?
One 23 times 10 something 11.
Very good. So that is called the index notation already.
Okay.
Notation. So in fact, right, your calculator will use index notation to represent huge numbers. So your calculator is no longer limited by the 10 digit, okay, the 10 digits boundary. Okay, so that's why we want to talk about index notation. All right, so with this, then you can actually make use of how you can actually use the power. So just now you say what, 1.00, okay, I cannot remember, just make use of this, times 10 to the power 11, right, you're talking about? Okay, good. So now you can see that you can actually have a power to the power of 11. So if you have the power to the power of 11, right, what is the opposite of this? Is square root, put the 11 out, then you just put this inside, then you will get back this one, right? Does it make sense to you?
Yes.
Something like that. Okay. Okay. In fact, your square root, okay, your square root and then 11, right, shouldn't apply to 1.0023 because you know why?
No.
Okay. In fact, okay, can I ask you? The power 11 is applied to the 10 only, right? Hello, are you still there?
Yes.
You have become a submarine. Like the, oh, I disappear entirely as well. All right. So I'm going to say like you have become a submarine recently launched by North Korea. And then now I become a submarine also. Recently launched by any other country launch a submarine recently?
Mars.
Elon Musk?
No, Mars.
Who is Mars?
MA.
Okay. But launch a submarine. Mars launch a submarine. Okay, I have no idea, but anyway. So okay, my camera take time to recover. But anyway, so just focus on. So the power 11 only applies to 10, right? The power 11 is not it's not applying to 1.0023 here, right? Can you see? Okay, by the way, when you write 2 times 3 to the power of 3, right? In fact, the power 3 is only attached to 3. The power 3 is not attached to 2. Please take note of this. So therefore, if you have this, then your power 11 in this case is only attached to 10. So when you use the square root power 11, you are not supposed to cover the entire thing, because if you cover the entire thing, you know that the power 11 doesn't apply to 1.0023. So that's the reason why this square root should just apply to this and then put the 11 outside. Then this square root 11 will cancel the power, the power 11, yes. Then you will get back the original. Does it make sense to you now? And that's how you make use of power more than 3 and square root or more than cube root. Okay? So with this idea, you are no longer bounded by the capacity of your calculator. Your calculator is going to show you big numbers in index notation, something like this. Okay? Okay or not? Can't hear you. Are you still there? Can't hear you suddenly?
Yeah.
Good. Okay. So I've demonstrated to you how you can actually do things more than cube and cube root. All right. In fact, you can be asked the number of hairs you have. So in fact, it's, I don't know, maybe in millions. So that's where you can actually make use of more than cube and more than cube root. All right. So we have covered these squares, cubes. Can you see the PDF now?
No.
You're not seeing the PDF. Okay, good. Because I'm sharing the whiteboard. I'm sorry about that. Okay, good. Now you can see the PDF. Okay, so we have just covered what? We have just covered squares, cubes, square roots, and cube root, and of course more than cube roots. Okay, and over here by prime factorization. So we are going to look at how this can be done. Some examples. I have this question. No, not here. Sorry about it. It should be. Is it here? Here. Yep. So let's test yourself against this question. You can, okay, there are some white space here. You can actually use your Apple Pencil and just do the Hcf and Lcm, and of course this over here. All right. Let me turn my camera on. Wow. When your holiday starts, can I ask?
Next week.
Oh, okay. 2 more weeks. Surprisingly, you are still going to school, huh? Why?
And we will only collect our results after the holidays start.
Yeah, yes, you are supposed to, yeah. Because it takes a few months, like two months. But I'm not sure why you P6 students need to go back to school, because everything is finished, right? I'm just puzzled. Any idea why?
To learn the topics we didn't learn.
Okay. All right. Okay, good. Camera's back on. Okay, you put a 2 and then you get 75 and 450. Mm-hmm. So yours is an iPad what?
Pro.
Wow. The latest generation?
I don't know.
Oh, okay. It's a super big one, right?
Kind of.
Like a MacBook size, right?
Like MacBook Air.
Wow. No, I mean MacBook Air is big enough. You know, you have an entire screen. My goodness. Oh my God. I think you can split screen and then I think you can split screen 3 times, like 3 screens. Then one screen is Zoom, then the other one is what? Bilibili, then another one is
How?
help.
Like how to?
You don't know you can split screen? Oh, I shouldn't teach you. Otherwise you will be doing Zoom and of course you put a YouTube next to it. No way. You can learn it yourself. I'm not going to teach you. But I think when you split screen, most likely your camera will be turned on. Yeah, that shows you are not paying attention, yeah, or you are splitting screen. Yeah, go and check it out how to split screen. That's what I do if I want to like listen to music, then watch YouTube, you know, multitask. Oh, but these days I seldom multitask already.
150.
Hey, hold on. Your 6 is okay. This is for you to find HCF only. This way can only find HCF. Okay. Okay, good. Okay, HCF is 150.
No. Oh, never
mind. Yep, HCF is correct. Yep, you can wipe this off and yeah, carry on with the LCM. How come you're using an Apple Pencil and you still write it so ugly? I mean your handwriting. I know my handwriting is even worse, but yeah. I know my handwriting is worse than yours, but still, you are using Apple Pencil. It should be better. Yeah.
LCM is.
You have lost your prime factorization just now because you wipe your you wipe your working off.
Oops.
Yeah, but anyway, okay. This is also the reason why I want you to use the method I proposed to you instead of the method you propose. Yeah, you redo. But anyway, yeah, I don't know how you're going to find the LCM.
I only remember the not logical.
Yeah, but I hope you don't do it. You don't want to start the wrong way. Yeah, because if you start the wrong way, then you continue. Then I'm not sure this wrong way. You are going to be penalized. So start the right way. Then yeah, find the prime factorization for 150 first, and then find the prime factorization for 900 first. Yeah, sure. You can split. You can split it. Yeah. Yeah. Good. This makes more sense. So that's 150. Good. Oh, just to let you know, one is not supposed to be there. Can you see your 5 and then you have 1? 1 is not supposed to be there because it's not a prime number. Yeah. So logically speaking, this one also wrong. 5 can be there, but 1 cannot be there. Yeah. Okay. So there are a lot of gray area. There are a lot of gray area for this method. Yeah. Okay, so you have the prime factorization for 150 and you also have the prime factorization for 900. How do you find the LCM then? Can you still remember the 2 ideas, the 2 tips I give you for LCM? Number 1 is?
Choose the.
No, before picking the power, you have to, the number 1. Number 1 tip is all prime numbers. Okay, so what are the prime numbers available here? You can just write it below the 900 prime factorization. Yeah, 2, 3, yeah, and 5. Yeah, so write them down first before you pick the power. So for LCM, when you pick the prime numbers, they should multiply together instead of the comma.
Okay.
Yeah. Yeah. So LCM, you should pick the not yet. Tip 1 is tip 1 is choose all the prime numbers available, and then tip 2 is choose the what power for LCM? Highest, yes. So for 2, the highest power is
2.
Yes. So just put the 2 on top of 2. Yep. Then for 3, the highest power is 2 as well. Yep. For 5, yep, both 2. So 2. Yes. So you just have to use your calculator and then figure this out. So looks like the LCM is quite big.
900.
Yeah. So given this, so can you write the answer down first? So write 150 below the question, write 900 below the question so that you can clear all this. Okay, you clear all this first because you are going to answer. Okay, stop. If you clear later, you will clear your 150 and 900 as well. So I want you to clear before you write down the 150 and 900. Am I right? Oh, you're using eraser. Okay, okay, it works this way as well. Yep. The last question is the question that is very popular in exams. Do you understand the question or not?
Yes. I mean, no.
No?
No.
Okay. Okay. Before you need to know the question, do you know what's the meaning of integer?
Engineer.
Integer. Smallest integer. K. The word integer here. Any idea?
No.
Okay. Never mind. So anyway, before we answer the last part, so yeah, so I just gave you an opportunity to practice HCF and LCM, all right, by using the prime factorization method. Okay, the 2 tips for each, please remember that. So in fact, this is also some definition. Okay, let's talk about our universe first. Our universe. So let's talk about human beings. Okay. So human beings are inside this universe. Your camera is off. So can I ask you, whenever your camera is off, what you are doing, like you
I
go out.
was turning. I was turning the brightness.
Oh, okay, good. Okay, you see, so when you do something else other than the Zoom meeting, so your camera will turn off. So that is an indication to us, yeah, you are splitting screen or whatever. Yeah. Okay. Okay, so if we talk about our universe, inside the universe, so we have human beings. So human beings, you can split to adults and children, right? Of course, you can talk about elderly. You can divide it further into elderly and babies and all those, right? But let's simplify things. Okay, we have adults and then we have children, right? And then for adults, you can also split it further into male and female, right? And then for children, you can split it further into boy and girl, right? So does this simple sketch make sense to you or not?
What about transgender?
Yeah, so let's make things let's make things simple, okay? So I don't want to talk about the LGBT stuff, all those, okay, or those non-binary, so can't tell the male and female stuff, okay? I don't want to go into that. So in our universe, human beings, basically we just divide it into adults and children, and then for adults and children, we can subdivide the adults into male and female, and then for children, boy to girl. And this is a simple representation of human beings. Okay, I don't want to go into details about the other genders or the non-binary and then binary and then what undefined. I don't want to go into all those. Okay, so in fact, for mathematics, we also have a math universe. Okay, in this math universe, right? So let's do this. In this math universe, we have real numbers. Okay, of course, when I talk about real numbers, you must be asking, then what are unreal numbers? Okay, what's the opposite of real numbers? Okay, the opposite of real numbers are unreal numbers.
Fake.
But again? No, not fake. No, we don't use the word fake. The unreal numbers are called imaginary. But we are not going to go into the imaginary numbers. We are not going to go into this because when you study until Sec 4, you don't need to know unreal numbers as of now. But if you go beyond Sec 4, then you will encounter unreal numbers. So we try to just focus on this math universe of real numbers. Okay. So when you go into the real numbers, right, then you can divide. Okay. You have rational numbers. Okay, you have rational numbers. And of course, when you have rational numbers, what do you think? You also have irrational numbers, the opposite of rational numbers. And I'm going to talk about what are rational numbers and what are irrational numbers. Okay, so far so good. Okay, so let's talk about irrational numbers first. Okay, irrational numbers like this: square root 11. Okay, square root 2, square root 3. Okay, so let me launch my calculator so you have an idea what are irrational numbers. You can also test yourself with your calculator. So I'm going to do square root 11. Oh, this is square root 2. Can you see? So square root 2, I get 1.41. And then, by the way, this is the capability of my calculator. In fact, it should go on and on. Okay, indefinite. And one more time, let's do square root 11. Okay, so once again, this is the capability of my calculator. In fact, it should be 3.31, on and on and on. Okay, and by the way, this 3.31 indefinite number is a decimal number, but this decimal number cannot be represented by a fraction. I want you to take note of this. This number cannot be represented by a fraction. Are you clear?
Yes.
Yeah, because of the irregular pattern here. Can you see the numbers are of irregular pattern? There is no pattern. Okay. Then of course you will see that square root 3 and then you don't have anything. I mean you end up with something like this also. Okay, 1.73 you know, on and on and on. Okay, so these are called irrational numbers. Okay, that means irrational numbers are numbers that can't be represented by a fraction. Okay, the numbers that can't be represented by a fraction, so they are called irrational numbers. So far so good. Okay, yes. but this irrational number can be represented by square root. Okay, so next time if you get square root something, so you will encounter later on. If you get square root 58, then if you turn out, okay, let's do 58 square root. So if you get square root 58 and you end up with such number, right? So the best is to represent your square root 58 just as 58, square root 58. Don't try to get it into this unless the question asks you to do two decimal places. Are you clear? Are you clear? So now you have learned another way to represent square root 58. So square root 58 is square root 58. This is an irrational number. Okay. Instead of, unless the question says, oh, you must represent in 2 decimal places, you know, that kind of thing. Then you go ahead and do 2 decimal places. Otherwise, you don't do it. You just leave it as it is, as an irrational numbers. Okay. Then when we talk about rational numbers, what are rational numbers? So rational numbers are example. In fact, I also have a picture of this. Let me see where is. Okay, here. Is it this one? No. Is it this? Yeah, over here. So irrational numbers, okay, over here. Pi is also an irrational number. Can you see? Because pi is 3.14 indefinite. Okay, I can't use a fraction to represent it. So irrational number here. For rational numbers, then out of, okay, in fact, for rational numbers, right, that means rational numbers can be represented by fraction. Meaning what? 1/3. Do you know that 1/3 is 0.3333333 and non-stop? You don't know, man? No, 1/3 is actually equals to 0.333 non-stop. Okay, but somehow your this 0.33333 you can represent by a fraction. So the 1/3 falls into rational instead of irrational. Does it make sense?
Yes.
Then of course you have the 2/3 as well. So 2/3 is like 0.66666 all the way, but it can be represented by a fraction. So I consider it rational. Okay, so inside rational numbers, you have 1/3, you have 2/3, but actually you also have this integers. Okay, integers. So inside integers, so seems like I don't have enough space here, so I'm going to just imagine this is integers. Okay, integers, you have 3 types of integers. You have negative integers, you have 0, and then you have positive integers. Okay, I'm going to give you examples of negative integers. -1, -2, -3, and -4, and on. Okay. What about -1.1? Do you think -1.1 is negative integer? The answer is no. No. The answer is no. This is not integer. Integer must be whole. Integer must be whole number. Okay. It cannot be fraction. It cannot be decimal number. That's called integer. Okay. Then 0 is integers. Positive integer, very simple. Positive integer means 1, 2, 3, 4, on and on and on. And so far so good.
Yes.
So far so good. Then inside integer, right? All the positive integer, they are called whole number. You know what's the meaning of whole, right? Whole means 1, 2, 3, whole. Okay. You don't have fraction, you don't have decimal, that's called whole number. So if you look at this once again, maths universe, real numbers, we're not talking about imaginary numbers yet. Math universe, real numbers, you have rational and irrational. So irrational, you have some examples here. Can't be represented by fraction. Go on and on and on. Rational number, it goes on and on and on, but it can be represented by a fraction. And then inside rational number, you have integers. So inside the integer universe, you have negative integer, 0, and positive integers. So this particular group of positive integer is also called whole number. So basically, you have learned what are real numbers. Okay. Then for real numbers, you have rational, and then you have irrational. And then for rational, you learn integers. Okay, you have integers. And of course, you have fraction. And of course, you have decimal. Right? And then for integer, you branch out further. Negative, 0, positive. And then this branch of positive integer is called whole number. So this is the thing. Okay? This is the tree branch. Okay? You don't have to know a lot about it, just to know what are some examples of these real numbers, rational number, irrational number. Just to know. Okay? Just to know. Okay? That's why with this, and you should be able to answer this question. Here. So I'm going to open it once again. It's box. It's sharing folder, and then this. Yeah, here. So this question means you already have 150 times 900. Then, of course, it's good to. Okay, over here they never ask you to write in index notation. But I think it's good to write down in index notation because it's easier to see. So it's 2 to the power of. Do you still have the work? Never mind, let me just quickly do it. It's good to represent in index notation. Later I will tell you why. Then for 900 is 2 times 3 times 5 square. And then this you need to times 6 is 2, 3. So you add. Okay, good, done. Okay, so with this, right? With this, so they are asking if you divide by a k is an integer, smallest integer, meaning the smallest integer k, such that k is a perfect square. By the way, to be a perfect square, so perfect square means this. It means it can be square root. Perfect square means can be square rooted. Okay, so what is this smallest k? You can fill in. So for integer, just now we talk about what? For integer, we have negative integer, we have 0, we have positive integer, right? So let's test negative integer. Can you do me a favor? Can you do square root negative 2? I think you can math error. Are you getting math error?
Yes.
So in fact, something like you can never divide by 0. You cannot divide by 0. So you can 5 divided by 0 cannot. So 0 can never be. This is some principles you need to remember. 0 cannot be the denominator. I mean, at least as of now, you have not reached that level that you need to know something divided by 0. Right? At your level, 0 cannot be the denominator. Same thing. When you square root, you cannot square root a negative number. Cannot. Just remember, you cannot square root a negative number. Okay, so for integer, this one is out. If you put 0, here, cannot, because 0 cannot be the denominator, right? So 0 also cannot. So basically, what is the smallest k you put in so that it can be square rooted? So a lot of students, they test. What's the smallest positive integer? 1. So if you put 1 here, can it be square rooted or not? How do you know? If you do it this way, I think you can only test. Trial and error. But of course, I don't recommend trial and error because 150 times 900, they are big numbers. If you go and do trial and error, I don't know when can you solve this question. So in fact, this question requires a bit of techniques. Okay, the technique is this. Let me erase the unnecessary stuff first, or let me just do it on the PowerPoint slide. So you have 150, you have 900, and you need to divide by a k such that it can be square rooted, and k has to be the smallest, integer. Okay, so I know that negative cannot, because square root you cannot square root a negative number. 0 cannot, because you cannot divide by 0. So what is this k such that it can be square rooted? In fact, you need to make use of the index notation. Then you will have a better picture. So the 150, I change it to 2 times 3 times 5 to the power of 2. The 900, I change it to this 2 to the power of 2, 3 to the power of 2, and 5 to the power of 2. Done. So this one is my 150. This one is my 900. Now I can do it already. Divide by a k. So I hope you can see something already. Just now what I say, square root is the opposite of square, right? Right?
Yes.
So can you see? Here is 5 to the power of 2. So that means you have 2 5s. Here is square root 5 to the power of 2. So that means these 2 will combine to 4 5s. So it's 5 to the power of 4. This is 3, 1 3. This is 2 3. When they combine, is 3 3. So 3 to the power of 3. This is 1 2. This is 2 2. They will combine to 2 to the power of 3. So in fact, I have so-called consolidate all this into here, and then divide by k, and then you square root 2. So when you square root, you know that you cannot square root. Square root is the opposite of this square, right? So can you see you have 2 to the power of 3? So what can you do? You can put a 2 here so that you will get rid of this, get rid 1 2 from the 3. So you have 3 to the power of 3. So you want to get rid of 1 3 so that you will have 3 to the power of 2 so that it can be square root. Do you have to get rid of a 5? No need, because 5 to the power of 4 can be square rooted. Okay, so the lowest k is 6. You understand?
Okay.
Yeah. In fact, for this kind of question, I need to give you a few questions. Then only you will get the idea how you can solve this type of question. Okay. But anyway, always remember, square root is the opposite of square. So in order to counter the effect of square, you need to have square root. All right. Okay. So I'm going to give you a homework. So I'm going to send you the link right now. Where can I send the link to, by the way? Just right here. No? Let me just send to your Zoom. No? Okay. I send to your Zoom. Okay. Then you can access. Hold on. Let me just send the link to your Zoom. By the way, do you have other questions for me before we end?
No.
Okay, don't end first. Let me send you the link first. Pretty fast. So I'm going to send you the link. Then you just do it from here. Share. Link. Sending. So sending. Hold on. Let me open this first. Funny thing. So how about your other subjects? I did not ask. Or PSLE?
Fine.
So you
Not
feel
too bad.
not too bad. Okay, good, good. Yeah, as long as you feel comfortable, you feel confident, I think yeah. So over here, so I think you can see my screen, right? So over here you can see what homework 0, then homework 1. So your homework will be homework 1. Okay. So if you finish, of course you want extra, you can go to homework 1A. Okay, but of course you don't want to go to homework 3 so fast. Okay, just step by step. If you finish, then just stop at there. No need to rush. All right.
Okay.
Good. I'm going to send you this over this Zoom right now. Then you just bookmark this. Then you should be able to access it next time as well. So let me just quickly send you. Yep, it's there already. Okay. Yep, I just sent you already. Can you see? Can you see?
Yes.
Okay, good. So not only you can see, you must be able to click on it. All right. Okay. So let's stop here and then thank you so much. Okay, bye-bye. I just realized I become a submarine. So sorry about it. Okay, bye-bye. Take care.